Hey guys, welcome to day 2 of your algebra class. I apologize that I can't be there today, but I want to start with a review for the quiz that you guys are getting ready to take. So just looking at the things that we discussed last week, we started with our operations with integers, so looking at a few of those, that's what you guys are going to see first. Don't forget the different rules for our positive and negative numbers. There was a difference between when we were adding two numbers that have the same sign and adding two numbers with different signs. And then there were some other rules for our other operations as well. But starting first with addition. So if I have, say, 6 plus 5, we know that that's 11. Sorry, my handwriting's terrible. So 6 plus 5 is 11. Again, technically, that's positive 6 plus positive 5 is positive 11. Right here, we're looking at two integers that happen to have the exact same sign, and that rule was to just add them together and keep the sign that they both already have. So we actually would look at negative 6 plus negative 5 in a very similar light. Don't forget, guys, that I'm just simply using that parentheses marker there to simply separate the operation sign, so the plus sign, from the negative sign there. So this is still negative 6 plus negative 5, which we know is then negative 11. That rule is still the same, that again, when we have two integers that have the exact same sign, so that's what we're looking at here. We have two negatives, so our rule was to add them together and keep that sign. Now, we looked at it a little bit differently when we had two integers that had opposite signs. So if I had negative 6 plus positive 5, now we look at it a little bit differently. Our rule for this one was we actually want to take the difference between our two values. So the difference between 6 and 5 is 1. And that wouldn't matter if it was 5 plus negative 6, it would be the same thing. This would still be 1. However, what we're going to do is we're going to keep the sign of the larger value. So it would be negative 1 in this case. So again, I only showed you this one at the bottom to show, if we had reversed the 2 from the top. So to show you that it doesn't matter what order it comes in, you just take the difference between those two values. The way to think about that is this. Remember we talked last week about so let me get that one out of the way. So looking at that first example, remember last week we talked about how you can look at this and relate it to money. If, say, again, negatives integers represent money that I owe, and positive integers represent money that I have. So if I owe $6 and I only have 5, then I still owe another 1. So that's why we have a negative in our answer. If this was completely reversed, so instead of negative 6, if this was positive 6, and we were adding that to negative 5. So once again, we're still seeing, a positive plus a negative, so opposite signs, but you can still think about that the same way. If I have $6 and I owe 5, then I'm going to leave that store still having, switch a marker here, still having $1. So that's why our answer was positive 1 in this case. That's just something to think about. Remember, when you're looking at addition, make sure you're paying attention to the signs of that addition problem, because remember, there's two different approaches to to any addition problem. So whether it's the same sign or not. So again, just looking at some different problems here. So if I have, say, negative 7 plus negative 2, I know that's negative 9. Whereas if it's negative 7 plus positive 2, the only difference between these two problems is this little mark right here. Because that first problem, we have the same sign, that's why we just simply added them together and kept that sign. In this problem down here, so in this one, it's a negative plus a positive. So because of that, that was that second rule where we simply just took the difference between our two values. So our answer here is going to be 5, since 7 minus 2 is 5. But because our larger value, which again is the 7 here, since our larger value was negative, so is my answer. So my answer is negative 5. And don't forget, you can always just check it again, take a second look at it by thinking of, again, that money scenario that we talked about. With subtraction, Remember with subtraction, what we did is anytime we have any type of subtraction problem, we can just look at it as add the opposite, or we also talked about the phrase add a line, change the sign. So if I had, say, 2 minus negative 8, something like this, then the way that we can look at this is simply just change that subtraction into addition. In order for us to do that, we simply just change the sign of the second integer, and it's always the second integer, so it's going to be this negative 8 in this case, not the 2. So we change the sign of that second integer and make it positive, since it's right now negative. So now we sit back and look at the fact that it's now an addition problem, make sure we're paying attention to the signs. It looks like we have positive 2 plus positive 8, so since they're both the same sign, my rule is to add together and keep the sign. Looking at another one, if I had, say, negative 7 minus negative, let's just say 3, then again, we can add a line, change the sign. So I change that to addition, change that negative 3 to positive 3. Now we sit back and look at this addition problem. It looks like I now have a negative plus a positive. So that's addition rule number 2, which says we take the difference between their two values. So this answer is going to be 4, since 7 minus 3 is 4. And since the bigger number is negative, so is my answer. So the answer here would be negative 4. And then remember with multiplication and division, on that one, the rule was, you still multiply and divide the same way you always do, but as far as the sign of the answer, that's dependent on the signs of your problems. Our rule was that anytime you have the same sign, our answer will always be positive. So if I had, say, just looking at 4 times 3. So if I'm looking at 4 times 3, I know that's always going to be 12. Even if it was negative 4 times negative 3. That too is also going to be 12, since they're both the same sign. Since they were both negative, that's why my answer was positive. Again, because they're the same sign. The only time you get a negative answer in multiplication is if your signs are mismatched. So if I had a positive 4 times a negative 3, now we're seeing mismatched signs, so therefore my answer is going to be negative 12. So we're still multiplying the same way. We're still going to get 12 every time we take 4 times 3. But make sure you're paying attention to the signs to see whether or not it's going to be positive or negative. And the same rule we used for division. So anytime you see a division problem, if I had, say, let's just say 30 divided by 5, that's always going to be 6. Even if it was negative 30 divided by negative 5, because they're both the same sign, I'm still going to get positive 6. The only time you'll get a negative is if I have mismatched signs. So let's say we have negative 30 divided by positive 5. Now I'm going to get negative 6. So it's still 6, but it's just negative because we have mismatched signs. So those were our rules for integers. Hopefully that jogs your memory on our integers, and that's the first thing you'll see on the quiz. The second thing you're going to run across on the quiz is our order of operations. So remember our order of operations, we remembered the phrase, please excuse my dear Aunt Sally, or maybe we remembered PEMDAS to help us remember our letters, PEMDAS. Remember, even though there's 6 letters up here, remember that is a 4-step order that we're looking at here. Step 1 is to solve all parentheses that are in the problem. Step 2 is exponents. Then step 3 would be both multiplication and division, and step 4 is addition and subtraction. Don't forget, multiplication and division goes together the same way addition and subtraction goes together. So taking a look at an example problem, let's just say I have, let me actually clear that out of the way so we can have some room here. Let's say I have 14 minus, let's say 5 plus 2, times, let's just say 3 squared plus 7. Okay, so we've got a couple things going on in this problem. So we need to follow our order of operations. Although we want to, anytime we see a math problem, the temptation is to want to read that from left to right. We actually have to follow the order of operations. So step 1 says to solve any parentheses. So any operation that we have inside of parentheses, and I do see 5 plus 2 in parentheses there, so I'm going to solve that. So we know that 5 plus 2 would give us 7. So I'm going to go ahead and rewrite what I'm left with then. So that means I'm left with 14 minus now 7. And then I'm going to write the rest of what's up there. So times 3 squared plus 7. Okay. So now, instead of taking 14 minus 7, I'm going to actually, as that again is a temptation, I need to go to the next step. And the next step says to solve any exponents. So you will see there is an exponent there. We have 3 squared. Don't forget what exponents represent. Exponents say to take this number, so our base in this case is 3, and multiply it this many times. So if our exponent is 2, that says to multiply it 2 times. So 3 multiplied twice would be just 3 times 3, which is 9. So therefore I'm going to fill that in with what we have left, writing our response there. So now that's going to be times, and we just answer that as 9, and then plus 7. Okay. So then moving, again to our next step. Our next step says multiplication and division. We do have one of those in there. I do see a multiplication problem right in there. So I am going to go ahead and solve that. 7 times 9, which we know is 63. So that means I am left with then 14 minus 63 and then plus 7. So our last step is the addition and subtraction. So addition and subtraction, again, as we talked about last week, we think that because A comes before S in our way of remembering the order of operations that we must do addition first. But that's not the case. What's going to happen is we need to read this from left to right, and whichever one comes first is what we are going to solve first. So the first step is to take 14 minus 63. So 14 minus 63, don't forget you can use the add the opposite rule there, which would be the same thing as 14 plus negative 63, and that would end up giving us negative 49. So I'm left with negative 49, plus 7. I got to make sure I'm following my routine here. So negative 49, then plus 7. Don't forget opposite signs. So because of that, we take the difference between our two values. So 49 minus 7 would be 42, but because 49 was negative, and it's our larger value, so is my 42. So my answer here would be negative 42. So you'll see a couple not as big as that on the quiz. So just make sure you're following those steps. As you see here, make sure that, again, if it helps to just write what you're left with, it helps you to then see what the next step is and where you need to go. So make sure we're following the order of operations on there. Okay. And also don't forget that squares count in step 2 as the exponents. So as we just on that last one solved 3 squared as part of that second step, don't forget that square roots work the same way. So if I had say 8 plus the square root of 25 minus 2, something like that, then again that step where we have exponents, this square root of 25 counts in there too. So don't forget, square roots represent, I'm trying to find what number squared would give me 25. So this is the same thing as 8 plus, we know the answer for the square root of 25 is 5. So this is 8 plus 5 minus 2. Now we read this and continue this problem. We would read this from left to right. 8 plus 5 is 13. And then minus 2 would give us 11. So there's the answer to that one there. So hopefully that helps with that. So don't forget that in step 2. Exponents and roots go together. All right, guys, next you guys are going to run into your absolute value. Remember we talked about how the absolute value of any number represented by these brackets, oftentimes if I have the absolute value, say, of negative 45, you'll see these little brackets around that number. So when I'm asking for the absolute value of any number, I'm asking for the distance from 0 on the number line. So 45 is 45 places away from 0, and negative 45 would be 45 places away from 0 as well. So remember, the square root of any number is simply just that number without any positive or negative sign on it. So because, again, it represents the number of spaces from 0. So the absolute value of negative 45 would be negative 45. The absolute value of 12 would be 12, and so on and so forth. We did then get into, making sure when we're solving different operations that are inside of these brackets that we make sure we still remember that it's just we're trying to find the absolute value of that answer. So if I asked you guys for the absolute value of, say, -3 plus, let's say, 17, and then I want you to take that and add that to the absolute value of, say, I don't know, let's say -5 plus -2, something like this. So, sorry, that's not a very straight line. So there's the absolute value. Okay, so what we'll do in each of these, when you have an operation inside those brackets, you simply just solve what's being asked of us in each problem, and then remember the absolute value of then that answer is simply just that number. So in the first case, so -3 plus 17, remember they are opposite signs, so our rule for adding those two together is to simply just take the difference between those two values, so that would be 14, and again, because my larger value, which was 17 in this case, was a positive number, so is my 14. So it really just says to take the absolute value of 14, which we know is 14 itself. And we're going to take that and we're going to add it to our answer over on the other side. So the absolute value of -5 plus -2 is actually asking us to find the absolute value of what? -5 plus -2, we know since they're the same sign, then therefore we just add them together and keep the sign, so that's going to be -7. So the absolute value of -7 we then know is 7. So our rule here, we're just going to go ahead and add those two numbers together, so the answer to this problem would be 21. 14 plus 7 is 21. So that's our absolute value. So keep that in mind. The absolute value of any number is simply just that number without any sign associated with it. Next on the quiz, guys, you are going to come across the applying of the distributive property. So remember the distributive property when we saw something like this. If I had 7 times 3x plus 2, for instance, then I want you to simplify this. I can't really solve this out since it's not equal to anything. I just want to simplify that, and simplifying actually just helps to remove those parentheses that are right there. So with the distributive property, we are actually just going to distribute what's outside of the parentheses to those numbers that are inside the parentheses. So this says 7 times what's in the parentheses, so we can take it and look at it as 7 times this and 7 times this, and that helps to solve that. Or, I'm sorry, to simplify that. So 7 times 3 we know is 21, so 7 times 3x would just be 21x. And then we're looking at that as 7 times +2, which is +14. So we're adding that to 14. So that is our answer. It doesn't go any further than that. I cannot simplify that beyond that number, so that's where we would stop. Even when you see things a little bit larger, it's the same way to apply that. If I had, say, 3 times, let's say, 4x squared minus, let's call it 2x plus 5. We're going to do the exact same thing. We're just going to distribute that 3 to this, and then to this. So doing the same thing, looking at the first one, 3 times 4 I know is 12. So 3 times 4x squared is simply just 12x squared. Looking at that next one, so 3 times 2 is 6, but we can look at this because of that subtraction sign in front of it, we can look at that as 3 times -2, which I know is -6 is a way to look at that, so that's going to end up being -6. But 3 times 2x is going to be 6x, so a way to look at that right there. So that was just that problem right there, 3 times 2x, or -2x. And then lastly, there's a plus sign in front of that so that we can look at it as +5, and 3 times +5 is going to be +15. So simplifying that as far as we can go is simply that right there. So 12x squared minus 6x plus 15. That's going to help us with what we're going to look at in the next couple weeks, not just this week, but also next week in simplifying of our linear equations. Okay, so that's all we had to do on the distributive property. We then looked at solving for x last week too. So if I had a problem that said x plus 7 is equal to let's say 43, something like that, then that means that something plus 7 is equal to 43. So this one might be pretty easy. Remember what we had to do is we had to do the opposite of what was currently being done to x to get it by itself. That's the idea. So since 7 was currently being added to x, we're going to subtract that 7, and that will help to cancel that out over on that side. But whatever we did on one side, we had to do the same thing on the other. 43 minus 7 over on the other side is going to give us 36. So that means x is what we get by itself on the left, and 36 is what we got over on the right. So that means x is equal to 36. Don't forget, once you get your answer, so our answer is 36, that could be plugged in for x in that original problem to see if we did do that correctly. Whatever our answer is, plus 7 should give us 43, and yes, 36 plus 7 is 43. So we are correct in that. Okay. All right. So very similar, just again when I say opposites, so we just saw that the opposite of addition was subtraction. The opposite of subtraction would then be addition. And then when we see multiplication, so if I had, say, 4x is equal to, let's say, I don't know, well, let's do a even answer here. So is equal to 24. So that means that something times 4 gives me 24. Again, you might be in your head thinking, okay, well, that's 6. But if we couldn't do it in our head, then that means what we're going to do is the opposite of what's currently being done. X is currently being multiplied by 4, so therefore we're going to divide by 4 to help cancel that out. And we do the same thing over on the other side, and that will leave me with x on the left and 6 over on the right. So therefore, x is equal to 6. Don't forget, if you ever come across something where maybe two things are being done to x, so maybe we see a number being multiplied or divided, and then we also have a number being added or subtracted. So let's say I have x divided by 3 minus 5 is equal to, let's say, 10. So in this case, we've got two numbers we need to get rid of. I have to get rid of both the 3 and the 5. Remember last week I mentioned to do the opposite of the order of operations when it comes to getting rid of numbers. So I'm actually going to get rid of whatever's being added or subtracted first, and then I will get rid of the number that's directly on the x, which is the number that's being multiplied or divided. So we start by getting rid of that 5. Since it's being subtracted, I am going to add it. And I'm going to add it to both sides. And then over here, that will cancel that out. Leave me still with x divided by 3. And then over on the other side, I'm left with 15. And then so now I need to get rid of that 3. Since 3 is currently being divided, I'm going to multiply to get rid of it. So I'm going to multiply that to cancel that out and multiply it over here on this side as well. So over on the left, that left me with x. But over here on the right, 15 times 3 is 45. So that means my answer is 45. Again, especially since now we had to do two things, great to double check that answer. If I plug 45 in here for x, that should give me this result. That should make that top statement a true statement. If I took 45 divided by 3, so 45 divided by 3, that would give me 15. 15 minus 5 absolutely is 10. So therefore we did do that correctly. Okay, so that's what we will see there in solving for x. So you'll see a couple of those. And the very last thing we talked about last week, we looked at writing algebraic models, and that was just a matter of taking a word problem using the variables that are given to you and just writing that out as an algebraic problem, so using just letters and numbers instead of words. So if I said something along the lines of, let's say, I want to use an example that's not what I'm looking at on the quiz right now, but something very similar. If I said Jill is 7 years older, I'm trying to show this as text, 7 years older than Stacy. If I said Jill is 7 years older than Stacy, and I'll even in the text you'll probably see the letters that you need to represent there. So you'll see, use S for Stacy, use J for Jill. Jill is 5 years older than Stacy. It'll say something along the lines of write an algebraic model to represent their ages in their relationship. So with that being said, since Jill is 7 years older than Stacy, that means she is Stacy plus 7. She's whatever Stacy's age is plus 7, and that will be equal to Jill, or Jill's age. So it's just a matter of taking text and then turning it into just letters and numbers, so writing it out as an algebraic problem. So you'll see a couple on the quiz where you can just take that and think of it very literally. You just have to translate that very literally. All right, guys, I hope that helps. Michelle has the quizzes for you today. If you have questions, feel free to ask Michelle. Michelle, I am available via text, so just shoot me a text and I'd be glad to help out if I need to do anything. All right, thanks, guys.